Hello. So now I will be showing the architecture of the lab control main GUI program. As you can see in front of you, this is the actual GUI that can control several equipment. The architecture of that program has the primary GUI here in the main file, lab control main GUI. There's two other important GUI, the data viewer, which can be accessed either directly, this can be run independently, or through the button here, data view data, when the main GUI is running. The edit config GUI allows you to change the save the config file that contains the available hardware. The sub-VE file contains all the sub-VE related to the main GUI with the config file. The variable contains variable related memory related VIs. Communication subfolder has important VIs related to communicating with our hardware. And a control contains all the LabVIEW controls used in the main GUI. Now, the the data folder can be used to simply put in your data as well as the logs. The important file that we want to look at is the hardware VI. This is where all the hardware are placed. You can find other examples and as well as help folders related to how build hardware VIs in that folder over here. The current equipment that have been constructed, the VIs that have been constructed are here. More can be added as you wish. Now each VI is said to be can be run completely independently of the main VI. For instance, the OSA Ando has its own GUI as well as variable sub-VI and controls. The Ando, every GUI has to be fitted within a specific space which actually corresponds to the available space inside our main GUI. For instance here, the Ando GUI has all the related parameters necessary for a OSA scan. It's important to have a button to close the VI, and it is highly recommended to actually have a button to initialize communication, because when the GUI opens in the main view, lab control main GUI here, it will automatically run. So if the VI runs by user selected address, it needs to have an independent initialization control. If the equipment runs through a config file, this is not necessary. The equipment can actually be immediately initialized. Now the hardware can be selected through the edit config VI. It is recommended to run the edit config VI to read the config file, and all the available equipment that are currently set in the config file will be listed. Each equipment has a name, an equipment ID number, which is used for the system to make sure that you have different equipments. And here the type of equipment, whether it is meant for measure, control, or both. This will define whether it can be set on the left control panels or on the right measurement panels. If you have several VIs that are related to the same equipment, the little panel here can allow you to see which number corresponds to which equipment VI. Each GUI that you create has to have a GUI file path, which is the VI that is put inside the main GUI in the subpanel, in which has to have a defined space as defined by here in the main GUI. Each equipment also requires a variable path. This variable is used to communicate information between the equipment and the main GUI. All the information, all the data that the main GUI, that the equipment GUI wishes to communicate or to render public to other equipments has to be placed into the variable VI. Now the other VI that is required for every equipment is the event task. This is a VI that is used to transfer tasks from the main lab equipment GUI to the equipment VI. You can select each of those three for every equipment and then simply either apply or click OK. OK will automatically stop the execution of the edit config as well. If you click close, no change will be applied unless you previously clicked apply. New equipment can be added as well as deleted. If you selected bad files, you will be notified. Now, as an example, if I return to my OSA, the communication variable is the same for must be the same for every equipment, and will take the following form. All VI related to equipment have a blue icon on it. The following data that can be communicated from the equipment to the either other equipment or to the main GUI is listed here. Scan setting is only used for scan equipments. This contains information about minimum and maximum values as well as units. Data is used to transfer data from measurements equipment to the main GUI. Passive data is a free-to-use buffer that can be used to pass information between various equipment. However, equipment that is meant to receive such data must obviously be used at the same time as the equipment it expects to receive the data from. The other important communication variable is the top event task. This simply is used to transfer information, task information, from the main GUI to the equipment GUI. The three tasks that can be transmitted is either a go-to task, which is meant mostly for scan equipment, and a measurement task, which is meant for measuring equipment, or the quit order, which is meant to close the VI. The architecture of every GUI should have the following: a event task loop with a event task structure, which is used to read any events that happen inside the GUI, such as when a button is pressed. Here are all the possible buttons or event that can happen. The user event should be present on all GUI. This is the special event of tasks that are transferred from the main GUI to the equipment GUI. You can simply copy this specific task to your equipment GUI. Now, all the equipment should have a second loop to execute any specific task it requires to. Those tasks can be listed into a type definition control named Q. The task can be changed in this specific control here. A data can also be added to a cluster in that control to transfer relevant data for different tasks. Now, depending on the equipment, the task can change a lot. Initialization is normally always present, as well as shutdown. For equipment VI, a measurement VI, it is expected to have a measurement task. And for scanning VI, it is also expected to have a moving task. Now, when the equipment GUI receives an order from the main VI to either measure, go to, or quit, it needs to execute its actual task relevant to its local choices, such as if it receives the order to measure, it will execute the measurement task, which will appear here. If it is ordered to quit, it will execute the shutdown task. If it is ordered to go to, in this specific case, it won't do much because this is a measurement VI, although some customization can be done in case the user actually does send a go to signal. In this case, it has been set to change the center value of the scan. As for the architecture of the main GUI, it has this similar form. A event task that selects what happens when you press any button. A task loop, which execute the action loop, which execute the different tasks which are generated. In this specific case, there's also a refreshing task for, this is a data to recover data. So this specific task is simply constantly waiting whether or not data is available. The communication, when data is transferred from an equipment to the main VI, the equipment sends an order to the main VI that a data is currently available. In this case, a task here is created with the information of which slot the data is available from. Then the COM variable of that specific equipment will be read and the data will be processed. Once all the data is recovered from the expected equipment VI, then a new position of scanning can be set, or the single measurement is done. So this completes the overview of the architecture of the lab control main GUI interface.